Welcome to True Projects. In this video, we are going to explain about a project titled PAM DenseNet, a deep convolutional neural network for computer-aided COVID-19 diagnosis. So now coming to the introduction part. The unveiling of PAM DenseNet, an advanced deep convolutional neural network, marks a substantial breakthrough in the domain of computer-assisted COVID-19 diagnosis. The enduring worldwide health crisis has highlighted the demand for precise and effective diagnostic instruments, and deep learning has emerged as a hopeful avenue for assisting healthcare experts in swiftly and accurately identifying the virus. PAM DenseNet, an innovative neural network structure, tackles these vital requirements by harnessing the capabilities of deep convolutional neural networks to autonomously detect COVID-19 in medical imagery. So now coming to the objective part for this project is to improve the precision and speed of detecting COVID-19 in medical images. Amid the global pandemic, making timely and trustworthy diagnosis is absolutely crucial. PAM DenseNet strives to harness the potential of artificial intelligence and deep learning to furnish healthcare practitioners with a robust instrument that can aid in the swift and accurate identification of COVID-19 cases through the analysis of chest X-rays and CT scans. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and Sequence for visualization are important. Second, here we have exploring the dataset COVID-19. Here you load and explore your dataset which contains information related to COVID-19. This may include statistical analysis, data visualization, and data pre-processing tasks to understand the dataset structures and characteristics. Next, here we have image processing. This step involves preparing your image data for machine learning. You can use the image data generator from a deep learning framework like Keras to perform various transformations on your images. These transformations can include rescaling, shear transformation, zooming, horizontal flip, and reshaping. These techniques are used to augment your data set and improve model generalization. The next step we have data extraction from image. This step is not only explicitly described, but it likely involves extracting relevant features and information from the processed images. This could be a critical step for feature engineering, especially if you are working with medical images related to COVID-19. Then next here we have splitting the data into train and test set. The data set is typically divided into a training set and a testing set. The training set is used to train your machine learning model, while the testing set is used to evaluate its performance. The split helps in assessing how well your model generalizes to new unseen data. Next here we have model building. In this step, you create and train various deep learning models using different architectures. The models you have listed: Inception v3, VGG16, VGG19, MobileNet, DenseNet 121, DenseNet PAM, DenseNet SAM, DenseNet SE, ResNet 18, ResNet 34 are popular pre-trained neural network architectures that can be fine-tuned for your specific task. These architectures are known for their effectiveness in various computer vision tasks. Next here we have training the model with train and test building the model. This step involves training your selected models on the training data and then evaluating its performance on the test data. The training process includes optimization algorithms like gradient descent and backpropagation. The trained models are built and ready for inference. Next here we have Flask framework with SQLite for sign up and sign in. You can use the Flask web framework to create a web application. Additionally, you integrate a SQLite database for user registration and authentication. This step sets up the user management part of your project, allowing users to sign up and sign in. The next here we have user gives input. User interacts with the web application by providing their input, which could be related to the COVID-19 dataset or an image. Then we have the given input is pre-processed for prediction. The input provided by the user is pre-processed to be compatible with the model's input format. For image data, this would typically involve resizing, normalization, and any other necessary transformations. Then we have trained model is used for prediction for about image. The pre-processed input is passed through the trained deep learning model to make the predictions. For an example, if your project is related to the COVID-19, the model might predict disease status or other relevant information based on the input. And the last one here final outcome is displayed through the front end. The model's predictions or results are displayed on the front end of the web application, allowing the users to see the outcome of the analysis. This outcome could be in the form of textual information, charts, or any other visualization related to the task. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Then we have another folder which is named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Next folder here we have which is named as data. This folder contains of the dataset which is used in this project. Then we have .ipynb file, which is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Then we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML template. And the last one here we have signup.db file. This file appears to be the database file which is used to store the information. Just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and the space the path over here, and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browsers. And I am using Chrome. So just paste the link over here and now hit the enter button. So here you can see that this is our home page for the COVID-19. This is all about the COVID-19, that the plant diseases compose a great threat to global food security. This is all about this. Here you can see that there is a button for login. Just click on this button. Here you can see that there is a button for sign up. Just click on this button and enter your username, your name, email ID, your phone number, and your password for doing the registration. I have already done the registration, so here I am clicking on sign in button. So just enter your username and the password over here which you have created while doing the registration and simply click on login button. So here you can see that here you have to upload the image to be classified. Let's click on the choose file button and let me choose the image from this. So here you can see that we have to choose any one of the image from this. So suppose here I am choosing this image and now click on open button and click on upload button. So by scrolling down below, here you can see that it is showing the image which you have uploaded over there, and the result is based on the input image, the patient is diagnosed with the pneumonia. So depending upon the image you are providing over there, it will detect the diagnosis of the patient, whether the person is diagnosed with the pneumonia or not. By clicking on the try again button, you can try with some other image. Let's click on the choose file button again, and suppose here I am choosing this image, and now click on open button, click on upload. So by scrolling down below, here you can see it is showing the result as the patient is diagnosed with the COVID-19. So depending upon the image you are providing over there, it is showing the result for according to that. Here you can see that there is a button for graph. Just click on this button. And here you can see that it is showing the name of the graph as the confusion matrix graph, precision and recall, ROC, cross validation, and ROC exhibit. So depending upon the image and the algorithms here over there, it is showing the accuracy of those graphs. Here you can see that there is a button for sign out. By clicking on this button, you can successfully log out with it. So now coming back to the conclusion part. To sum up, PAM DenseNet marks a substantial leap forward in the realm of computer-assisted COVID-19 diagnosis, offering a hopeful answer to the urgent issues brought about by the worldwide pandemic. This advanced convolutional neural network has shown its capacity to enhance the precision and effectiveness of COVID-19 identification in medical images, especially chest X-rays and CT scans. By automating the task of recognizing patterns associated with COVID-19, PAM DenseNet aids medical practitioners in delivering quicker and more dependable diagnosis. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.